In lesson 3, the type of projectiles we're looking at now are the ones that are launched into the air and return to the ground at the same height from which they were launched. So what I'd like you to do is draw this parabola, which is the dotted line represents the path of motion for this type of projectile. Then I want you to draw a dotted line down the middle as such. This point is where the vertical displacement is at its maximum. We could also say that time at this point is where the y is at its maximum, so we say ty max. So to determine initial velocities, like with all the rest, we use our formulas that we derived from trig previously. In this type of projectile, the relationship between the initial vertical and final vertical velocities is that they are opposites. If your initial vertical velocity, say, is 20 meters per second, your final vertical velocity is minus 20 meters per second. Now, at this halfway point, the point where we say is the max height, we already know a couple of things. Firstly, the vertical velocity will be equal to 0. And secondly, because that vertical component is 0, the velocity will equal ux, and obviously ux is unchanging. From this information, we can determine a few things. The time of max height using v equals uat, and also the max height of the projectile with the max height time using the delta y equation. Because projectile motion follows an even parabola, the total time is equal to twice the time at max height. So you've calculated half the time, times it by 2, you get the full time. So let's now look at an example. A projectile is fired at 30 meters per second at 50 degrees to the horizontal. Calculate the following. We're given the initial velocity u of 30 meters per second. So firstly, in this case, determine the initial vertical and horizontal velocities. So let's do ux first, u cos theta, blah, blah, blah. We get 19.28. Then we can do uy, and we get 22.98. Then let's calculate the time at max height. Now, as I previously said, the best way to do this is using v equals uat, where vy equals 0. That'll give us a time of 2.34, and if we multiply this by 2, we will get the total time. Using the total time, we can then calculate the change in x using our original ux value, and we'll get 90.44. And using half the total time, that's that original value with the ty max, 2.34. If we put that into our delta y equation, we can find out the max height. So if you apply those basic principles associated with this type of parabola, most problems should be pretty straightforward to work out. So get started through those questions.